Hello, everyone, and welcome to the first session of the Solidity Bootcamp that we are doing for ETHDenver hackers. Actually, the session is open to all, but this is going to be the series of sessions is going to be a very mini bootcamp, so you can learn as much as possible about Solidity and try to hack at ETHDenver. ETHDenver is a conference up and coming in Feb. It's going to be starting in about a week's time. Event starting from Feb 14th up until Feb 19th, 20th. ETHDenver is both in person and virtual, so you can hack either ways if you have registered for the conference and the hackathon. So this entire mini bootcamp is going to be split into 4 sessions. We are going to have intro sessions on Ethereum, smart contract, Solidity. We're going to solve a couple of quests on Questbook, and we're going to learn more about how to implement actual problem solving using Solidity. So today's session is the first ever session. It's going to be about Ethereum, smart contracts, and an introduction to basics of Solidity. My name is Gyan, and I work with the research and content department, or rather, the research and the content arm at Questbook. At Questbook, we are building a grant orchestration tool that will help bridge the gap between protocols and communities or individuals or groups of individuals who are trying to apply for grants to these protocols. So more about that probably in person at ETHDenver if you're going to be attending. I have about 6+ years of experience in blockchain, and I've done several talks. I have been working on a couple of projects, a couple of interesting ones, which I would love to share if we are able to catch up in person. So let's get started today. The initial theory slides might be little text heavy, but I just wanted to condense a lot of material in a very short time possible. Apart from these sessions, I would also highly encourage to go through the recommended reading, so you will be able to make sense of the bigger picture. So a quick introduction to Ethereum. Ethereum is a popular blockchain. It's a layer 1 blockchain. It's been there for a while. It was proposed in the late 2013 by Vitalik Buterin, who is a cryptocurrency researcher and programmer. It's open source. It's a public blockchain, and it's basically implemented the functionality of something called smart contracts, right? To run this blockchain, or rather to transact on this blockchain, you need the native token of that blockchain called Ether. Ether can be also transferred between accounts and can also be used and is also being used currently to incentivize the miners. Of course, as Ethereum is going to move to Ethereum 2.0, the whole concept of mining is going to go away, and a proof of stake consensus is going to come into picture. One of the most important things, and this is a terminology that you will hear being associated with several other protocols, is known as EVM, or Ethereum Virtual Machine. So what is Ethereum Virtual Machine? It's a decentralized virtual machine which is used to execute the smart contracts or the scripts using the Ethereum network, right? Using the network of nodes that forms the Ethereum blockchain. So EVM is basically as the Ethereum virtual machine is being used in several other protocols which are calling themselves as EVM compatible. What that means is, if you know about the inner workings of EVM and you have essentially learned about Solidity or just even the basics of Solidity, you know how to write smart contracts, you can build applications for all the protocols which are EVM compatible, right? Not all of them may have the same rules, but if they are EVM compatible, you can program using Solidity and build an application fairly easier on that particular protocol. So here is just a quick a brief overview of accounts in Ethereum, because it is very important for us to get started with Solidity. There are two types of accounts that share the same address space, right? The first one is an external account, which is controlled by the public-private key pair. External accounts are nothing but your wallet accounts that you create in order to transfer ETH. You create accounts in order to perform some transactions, etc. Right? So these are external accounts. There are contract accounts, right? So smart contracts are entities. Basically, they are just a piece of business logic, right, that you deploy on the blockchain. It's like an agreement, right? So these smart contracts, when they are deployed on chain, there are accounts called contract accounts that are created for the smart contract, which hosts the smart contract code, right? So the contract accounts are stored together with the external account. Now, a simple example or a workflow of how the external internal accounts and how do the transactions happen, right? So an external account, okay, let's see the second one. An externally owned account can transact with another externally owned account. So a simple example would be sending ether, right, from one person to another. Now, an externally owned account can also transact with a contract account. So it can create a contract, it can call certain functions in the contract, it can interact with the contract, etc. Right? So if you have seen any decentralized application, so for example, if you have used Uniswap to swap from one token to another, right? So Uniswap actually from an externally owned account, that is your account that is connected to the Uniswap app, you will be calling a particular contract, right, which is on the contract account, and you will be executing some functions like swapping or or providing liquidity, etc. Right? So an externally owned account can transact with a contract account, and internally a contract account can also call another contract account. So when one contract calls another contract, these are called smart cross contract calls, right? So you can, an external account can trigger a transaction to another contract account through an intermediary contract, right? So this is a possibility too. So here are the different ways transactions work in the Ethereum blockchain, right? Another terminology that we want to demystify, that is gas, right? I'm sure if you have used any kind of blockchain, or you are in the Web3 space for a while, you must have heard about what are gas, what is gas price, what is gas fees, etc. Right? So basically, every computation or transaction that happens on the Ethereum network incurs a transaction fee, which is calculated in units called gas, right? Why is it required to pay this transaction fee? One thing is we need to incentivize the miners, right? So we need to pay them some amount of fees. Now, why is this fees being paid? This fees is being paid so that the compute of that network happens in a decentralized manner, right? So how do you pay this gas price? You pay this. So for example, if for the context of this entire set of sessions, let's keep Ethereum blockchain as our main chain, and then we can work with other EVM chains follow similar behavior. So gas price is the amount of ether that we need to pay in order for the transaction to go through, right? So I'm saying here amount of ether because it's the native currency of Ethereum. It would be similar for other chains, right? Their native currency. Now, why do we have a separate entity called gas price or gas? And why don't we just pay in ether directly, right? Why don't we just call it ether price or something like that, right? That's the idea. That's because Ether in itself is a volatile currency. And as we all know, have been seeing the market for a while, its value keeps going up and down and keeps changing as per the market state. Though Ether is a volatile currency, we can calculate the bytecode, or rather the the price required to execute a particular smart contract, or even execute a particular function within a smart contract. We can calculate that roughly by using the bytecode of the instructions, right? So that's why we have an entity called gas, which is more or less a fixed price based on the opcode of the instructions, and therefore it is easier to calculate the amount required for a transaction when it comes to contracts in the terms of gas. And of course, that can be used for that kind of got extrapolated and is now being used for to represent all kinds of transaction fees. One more terminology that we want to decrypt here is way. You would see this being used popularly, way or gwei. So way is nothing but the smallest unit of ether, where 10 to the power 18, so there's a small mistake here, 10 to the power 18 way represents 1 ether. Okay, smart contracts, right? So what are smart contracts? Smart contracts are computer programs that comprise of the business logic for your applications. For example, if you want to build an application which is based on staking, right? So you need to think of a business logic as to how a user can come and stake, how much returns will they give on staking, and all of these things, right? All of these logic can be codified in the form of smart contracts and deployed on the blockchain. Once a smart contract is deployed, it is very difficult to change anything on the smart contract and it remains immutable, right? This is due to the inherent property of how data on blockchain works, right? Because it is encrypted using cryptographic hash. It is almost impossible to play around or change the data, right? You have to think very carefully before deploying a smart contract on mainnet, because once you have frozen the logic, right, it is very difficult to change that, as I just mentioned. So one of the best ways that we could do it right now is to either use proxy contracts or upgradable smart contracts, or you would have to redeploy a new contract onto the network. One of the things to understand about smart contracts is that they operate with a very limited execution context. What that means is they can access their own state, the context of the transaction in which they are present. It could be while they're interacting with the smart contracts or while deploying, etc. And some information about the most recent blocks. It may not have information about the entire blockchain or the history of the blockchain unless and until such kind of logic is pre-coded in your contract. All right, so now we get started with what we are here for, that is the Solidity smart contract, right? So Solidity is a development language in which a smart contract can be written, right? Now there are a lot of questions whether you need to already know a programming language in order to be able to develop in Solidity. How much of a programming language do you need to know? What should be the competence, prerequisites, etc. Now, from my personal experience, and I have been working with Solidity for over 6 years now, it is enough if you know a basic scripting language, something like JavaScript, right? If you are familiar with JavaScript, the constructs of JavaScript, and just in general how a particular programming language works and how algorithms work, I think you should be able to dive right into Solidity. However, if you already are from a Web2 development background and you're familiar with either front-end development, back-end development, then it's only going to be much easier for you to build an entire end-to-end decentralized application. Once deployed on chain, a smart contract will have its own name, of course, and a unique address using which we can access the contract from the web, right? So if you want to make any front-end plugins and you want to use the contract you want to interact with the contract using front-end frameworks like Angular or React, you can use this unique address given to the contract. Each smart contract, of course, will have some metadata associated with the contract. That is, what is the compiler that you have used? What is the language? It could be Solidity or any other language. What is the output, the version? If it is Solidity, what is the version of Solidity that you have used, etc. Right? Once the contract is compiled on EVM, it is compiled to something called as a bytecode, which is a language understood by the machine, right? And one of the other things you would have popularly heard is an ABI, right? So an ABI associated with a contract is nothing but an application binary interface, right? So it is a data encoding scheme that is used to work with smart contracts. Now, in order to interact with a particular contract or in order to call a contract instance, it is required for you to have the ABI of the contract as well as the unique address, that is generated after deploying that contract on chain. For most purposes and for beginners or even intermediate to advanced programmers use this editor called Remix Editor, which is an online editor, a browser-based editor on which you can easily write the Solidity code. The Remix Editor allows you to use different types of providers, right? What these providers do is that they provide you with the access to the network, right? To the blockchain network. So for simple testing purposes, you can use the JavaScript VM, which is a simple virtual machine that's a local blockchain and it creates accounts for you, right? You would have 10 accounts, test accounts, with each of them pre-populated with some 100 Ether, and you can test the functionality of your contract. The injected Web3 option will allow you to use an existing Web3 provider like a MetaMask extension or any other wallet that you might be wanting to use, right? You can configure to connect that provider to a testnet or a mainnet, that is either a test network mimicking the main blockchain or the mainnet, which is the main blockchain network, right? So injected Web3 allows you to interact with a real network. And the third option that you will see on Remix is a Web3 provider. That is, you can supply even your own unique blockchain's RPC address, right? Um, in most popularly, it would take an RPC address of an Ethereum client. However, I have not, uh, I guess Remix supports EVM. So you can supply the RPC of a Ethereum client that you are running, right? This will provide you with maximum control and you connect to your own node, right? If you're running your own node, you can provide the RPC address of that and you can use that. Now, of course, we are going to be spending most part of the session today in writing a couple of contracts, especially beginner friendly ones. But before we go to the contracts, let's just take a look at, what do the different keywords in Solidity mean? So before we start our Solidity contract, we need to mention as to which version of Solidity does this contract want to consume. So we can use the command pragma solidity and then mention the exact version name, or you can use an up symbol to mention that you can use from version 0.8.0 upwards, right? You can also mention something like less than a particular version and greater than a particular version, etc. Right? Now, the pragma keyword is used to tell the compiler as to which version of Solidity is this contract going to use. The next thing is, of course, a keyword to create the contract. And the keyword is simple, it's contract, all small. Followed by that, you can write the contract name, and within the curly braces, your entire contract code will come. A couple of simple syntaxes to keep in mind. If you want to write a variable name, you need to mention the variable type first, right? Like uint or string or whatever is the type of the variable. The access specifier, that is whether it is public, it is private, it is internal, or is it external, followed by the variable name. So there are four types of access specifier. We have external, internal, public, and private. As you can see by the names themselves, externals can't be accessed internally, only externally. Public, everyone can access. Private can be accessed only from this contract, and internal are internal only to the contract. We can define a constructor for a Solidity smart contract by using the constructor keyword. The visibility for the constructor keyword has been, we don't need to give the visibility anymore, right? So it is constructor and just the parameter list followed by curly braces within which you can write the constructor code. Events are special features in Solidity, which are like logs. So you log the events on chain, and events are used to get information about the transactions at various steps in the contract. So you can create an event using the event keyword, and you can log the event using the emit keyword. Okay? Struct is a user-defined data structure that is used to think of it as a class which encapsulates all all the data, as well as um, basically you all the if you want to create a variable that encompasses certain set of data, you can create that using a structure, and you can refer to that throughout your program wherever you need throughout your contract. One special data type that is there in Solidity is the address data type, which is used to store the different types of addresses. Right? All right. So today what we are going to do in this session is we are going to be solving a couple of quests on openquest.xyz. So if you haven't joined our ETHDenver study group Telegram, please go ahead and join it. All the updates, the reading recommendations will be posted on the Telegram group. Now, if you just go to openquest.xyz, you will be able to see that there are various tracks. Of course, as we are interested in exploring Solidity on Ethereum, we are going to go to the Ethereum track. Now, we have a lot of different quests that you can explore, and some of which we will do together as part of the sessions, and some of which you are free to explore. Of course, there are also other quests on Polygon, on Solana, and Near that you are free to explore. Let's go to the first quest, that is Hello World, right? So this quest is quite simple. We are just going to write a code in simple increments and understand the basics of Solidity programming language, right? So we are going to, of course, write this in Solidity, and let's go with the code, right? So just to do this together, and I encourage everybody who's able to join this live session that you do it along with me, because that's the whole purpose of the live session. Of course, you can also watch the recording and do it later, but I highly recommend you to do this session right now with me, so we are all on the same page and you also get to practice. So I'm going to create. All right, quick tips about Remix. You have these four small symbols that you can see. On clicking the first one, you can create a new file, you can create a new folder, you can publish your current workspace files to a GitHub gist, and here you can load a local file into your current workspace. The File Explorer button gives you the ability to do everything with files. This the symbol this is a Solidity compiler symbol, the second symbol that you see. You can choose the version of your compiler that you would like to use, right? And the third symbol that you see, the ether kind of symbol, is basically it allows you to deploy and run transactions. And the third symbol that I have enabled on mine is a debugger. Now, if you don't see any of these symbols except the File Explorer one, you can see a small plug like symbol, which is a plugin manager. You can click on that and search for, say, for example, compiler, right, which is already activated in mine. And to run and deploy, right? Let's see, deploy. Yeah, contract deployer. Oh, no, this is deploy and run transaction. So I think that's enabled by default. Then if you want the debugger, you can search for the debugger as well and activate that. Now, what I'm going to do is I'm going to create a new file called helloworld.sol. .sol is the extension for Solidity Smart Contract. My apologies, I had to open up a new Remix browser because the other one is kind of glitchy. So I've created a new file called helloworld.sol. .sol is the extension that is used for Solidity Smart Contract. I'm just going to say hello world Questbook. Let me just increase the font a little bit so it is clearer. Right, now from Solidity 8 onwards, it is essential to give the license identifier. I'm just going to say unlicensed, right? And I'm going to say that I'm going to use Pragma Solidity version 8 and above, right? Now, if we look at the code, this one is using 8.3, right? And you can see that we are creating a contract called hello world, and we are just creating a variable, a public variable called greet, right? So let's copy this code and just paste it here. Yeah. And I'm going to save this, and you can see that there is a tick here. So when I click on this, I have actually, you can enable auto compile. So every time you save, right, it automatically compiles. And if there's a green tick, what that means is your contract is compiled successfully, right? And you can see that I have chosen the compiler version 0.8.7, which is greater than 0.8.3, right? Now here, we can see that the contract keyword is used to create a new contract, right? Now my contract name is hello world. Within curly braces, I can define what logic is supposed to be there in my contract. At the moment, I'm just defining a public variable called greet, right? Which is of string type, to whom I'm assigning the value hello world, right? Now, okay, all right, let's compile this. And I'm going, like I said, there are different types of VMs that I can choose. I'm just going to choose a simple JavaScript VM, which has given me X number of accounts, right? I believe it's more than 10 now. And each account has some balance. Why do we need some account balance? We need this account balance to deploy this contract on the network, right? Why do we need some balance? Because this contract would consume some amount of transaction fee, right, in order to deploy on the contract or deploy on the network, right? So I have chosen the hello world contract. Be very careful. Once you click on the drop down, if you have other contracts that you have defined, you will have to carefully choose the contract that you want to deploy, right? Right now it is testnet, it's just a virtual machine. So I'm just going to, deploy this. Once I deploy, okay, I should be able to see a message over here. Let me just enlarge this. Yeah, so you can see that just below over here, you can see that there is a green tick. That means this transaction was successful, right? If we want to click and see more about the transaction, we can see that there's a transaction hash. There is a from, which is my account that I selected. So this is an external account. From this account, I have deployed a contract. Now this contract also has gotten its own address, right? Like I said, each contract will have a unique address. And the address of this contract is this, right? 0xd91 something. We can copy this and view this over here as well. Yeah. So you can see that a unique address for this particular deployed contract has been created. Now, in Remix, one of the fun things is that if we have a public variable, there is automatically a getter that gets created, right? So here, if I click on greet, I should be able to get the value of greet, right? So I got the value that I had programmed, hello world. Now you can tweak this value and try and but if you tweak this value, you will need to redeploy the contract. Remember, we said that contracts are immutable, right? So once you have deployed this with hello world, the greet for this particular contract 0xd91 will always remain the same. But what I can do is I can just change, right? I'm going to save it again and I'm going to deploy it again, right? I've deployed this and got another new address, right? Let's see the old one. And yet again, the greet has been set. And now you can see that the value is changed. So every time you deploy a contract, whatever variables that you have created static, their value will remain the same throughout the lifetime of that contract, right? So that's a simple hello world. And if you have written this, you have compiled this, and you have deployed this, that means you have deployed your first ever Solidity smart contract. Now, when you're doing this with the help of OpenQuest, of course, you can also claim your NFT once you have completed the quest, right? Let's take a look at a couple of other simple quests, that is reading and writing a state variable, right? Now I'm going to just use the same contract to write the code. So I'm going to remove this and I'm going to write the code within this. Now, we are going to create a variable called num, right? So let's do that. It's a public variable called num, right? I'm going to delete the previous instance of the contract. Now, every function call that we do is basically a new transaction, right? The last time when we called greet, there was a new transaction that happened, right? Now, to write or update the state variable of a particular contract, we will need to send a transaction and pay the fees, right? That is to write or to change. But if we want to read a particular value from the contract, it is free, right? We don't need to pay any transaction fees. So let's write a function that will just read the variable num, right? So to write a function, the syntax is very simple. We are going to use a keyword called the function keyword, right? And we are going to write the name of the function. If we want to send any arguments, we can send that within these round braces. Then we specify the visibility of the function. That is, we want to keep it public because we want public to access the value of num. Now, let's forget about this keyword for a moment, right? View. We can return value from this particular function using the returns keyword, right? And what type of value do we want to return? Uint. Why uint? Because num is a uint variable, right? And we are going to return the num variable. Now, the num variable, because it is public, as if you remember the access specifiers, it is accessible within the contract, right? As well. Of course, it is accessible outside as well, right? Now, the keyword view is an added permission to this particular function, which says that in this function, we are only viewing a particular value. That is, we are not going to change anything on the chain, right? We are not going to make any state change for this particular variable. We are only interested in viewing a particular variable from chain, right? That's where we use the keyword view. All right, now, similarly, if we want to write to a state variable, that is, we want to make some changes, right? Let's copy this piece of code then. We are going to use the same function keyword, right? Write the name of the function. Here it is set. But what are we doing here? We are going to change the value of num to another value that is being sent to this particular function. Here you can see that we have not specified any variable, any specifier like view, because here we are changing the state of the variable. So it's not a view function anymore. We are also not returning any variable here. If we want, we can return the updated value of num. So let's do that and let's return num. Now, one more thing I want to show you here is that if I don't write this, right? Now, Solidity gives me a warning that there is an unnamed return variable, right? That means I have not defined anything over here, right? I have not returned anything, but I'm saying that this function returns. Though this is just a warning, it is useful to know that if you make any mistakes, Solidity is able to give you warnings as to what went wrong, right? So I'm going to remove the comments and I'm going to retain the return, right? So now we are able to read and write. We have written the code to read and write from chain, right? It's already auto compiled, so there's already a green. I'm just going to deploy this. So I'm going to use, again, since I'm just calling it hello world, I've deployed this. Now, currently the value of num, the initial value of num is going to be 0, because that is the default value of a uint variable when created in Solidity. So if we try to click on get, we are going to get 0, right? We have not set anything, but we have the ability to set a value for num. So we are going to set it to 10, right? And then I'm going to get the value of num. Now it is 10, right? Now, because this is a public variable, I can also directly get the value of num because remix gives me a getter, right? So it should come as 10. So now we have progressed to the next level, and now you can read and write data in Solidity using Solidity, right? And of course, if you complete this, you will also be eligible to you can earn your own NFT, right? So basically, if you think about it, whatever programming logic that we write, there is just the business logic that we want to execute, plus, and most of this business logic is in the form of reading and writing data, right? So you add some conditions to it saying that if this happens, then do this, if that happens, do that, etc. And you either read the value and compare it to whether it is the kind of value you want, or you write the value and change it based on certain conditions. So to be honest, actually we have learned almost everything that we need in order to get started with writing business logic. But of course, there are a couple of other things like syntaxes which you need to know. That's why in this session, I'm just going to cover until this part, because I want you all to take your time and do the quests, which will talk about the other concepts like if else, mapping, array, and function. So these are the 4 quests that I would request you to do by yourself. So you have a good understanding of how the different constructs in Solidity work, right? Now, I'm not going to do these quests, but I'm happy to just go through them and show you quickly what they're doing. So as the name suggests, this is just going to be talking about if else. So you're going to write some if else conditions and perform certain actions accordingly, right? So if you're going to create a variable, if that variable is having certain value, return something, if not, return something else, etc., right? So this is a simple quest. Now, there is a quest on mapping. So I'm just going to talk about mapping for just a bit so I can introduce you to the concept. So mapping is nothing but creating a hash map, right? So a mapping consists of a key value pair, right? So so for example, this is an address to uint mapping. So this is the key will be your address and this is the value. So think of like if you are building, some kind of banking problem statement, right? So you want to know who and all has how much balance, right? So which accounts have how much balance. So you can create a mapping to the account from the account to their balance, right? So that's exactly what the uh, m- uh, mapping data structure, I would say, construct is doing in Solidity. And the syntax is mapping the key value key type of value, the access specifier, so public in this case, and the name for this particular mapping, right? So you're just going to use mapping and write a small function and delete the mapping and all the associated functions with mapping. What and all can you do, right? Arrays are simple and straightforward. I'm not going to go into this. Functions, you have already seen functions. You have already written them. Here we are just going to play around with how you can return multiple values from a function, how you can return named values from a function. For example, instead of over here, I can just say return uint now, right? So this is a named value. All right. So it gives me a warning because the same variable type name is there. But in case I want to return something else from here, say for example, uint x, I can do that too. I can just say x is equal to num and uint x is equal to num, and I can just return x, right? So this is okay. That's fine. So you can return named values, you can return multiple values, you can return without the return statement. You can, how do you destructure the return? So you can see that you are returning X number of values and how can you destructure them in another function. And of course, the limitations of functions as well, what you can do and what you can't do, right? Yeah, so these are pretty much the basics. One of the other recommended reading material for this particular beginner session is the Solidity official documentation. Solidity official documentation always has the updated information on what works for this particular Solidity version and what doesn't, what are the breaking changes, etc. So if you are planning to use a Solidity 0.8.x version, then I highly recommend to go through the Solidity docs, the latest version, and you'll have almost all the concepts I've covered in here. But of course, this could be quite overwhelming for beginners or even intermediate folks, because there's just too much information. But always good to have handy the Solidity official documentation, since it will have all the changes that are in the most updated fashion, right? Keep solving these, at least ensure that after the first session you're able to solve these first 6 quests, and if you have any doubts you can put it on Telegram and we'll try to help you. We also have a Questbook Discord channel where we have forums to help folks who are doing our quests, so you can always join that as well and take the advantage of the community there. Once this session is done, this is just going to be, this was just a basics of Solidity. We are going to start working with our first end-to-end contract, which is building a bank with Solidity. That isn't a toy. This session will take place tomorrow at the same time, and I'm looking forward to seeing you all at the session. Thank you everyone for those who were able to join today, and keep coding, keep writing your Solidity contracts, and keep solving the quests. And we are happy to help you or take any questions.